Of course, we will also need to consider the problem of maintaining the structure of a tree, so that after the building process, we will handle a data structure that can act as a hypothesis, that can act as a predictor given new data. So let us consider the one-step building. That is, we have a group of training samples with the observation of attributes x values and the target value y. We want to find one particular attribute according to which, if we distribute the data samples according to the value of that particular attribute, we will have subgroups of samples that when we build a subtree node, the children node for each of the subgroups, we are building a tree that best facilitating the decision-making process. So the input of this process is a group of data samples x and y, and the output is some decision. This is a vague concept. By decision, I mean we will have to decide, we will check which attribute, or whether we will need to check any attribute at all. If we do need to check attributes and do further splitting, which we need to check. So the steps are intuitive if we have already understand and state the problem in this way. Obviously, if for the given group, if all of the target value belongs to one class, then there is no need to make further investigation. We don't need to check any attribute because this group of samples are pure enough that we are happy to return the particular answer that the class is C at this point. So the node is the final node, it's the leaf node of the tree. The building process ends at this point, at least for this branch. On the other hand, we need to test each attribute of the given sample. We will loop of each attribute A, and then we will check we will split the group of samples according to their value of the attribute A, and we distribute Y according to the subgroups, and then we compute the information gain of the subgroups compared to the original group. And how to compute the gain of information if we ask questions about the attribute A and split data in that way. That is called information gain, and we will discuss this computation later. After we have looped over, we have checked all the attributes, we will have the idea of what is the best attribute to investigate at this step, and then we will split. We will distribute our samples according to the value of the samples having at the attribute A, the particular attribute. And the procedure is not surprisingly recursive. Then we will check each of the subgroup using the same procedure until we will find that we arrive at somewhere that all the target value are the same, and we do not need to split the groups of the samples anymore. Here is example. In the sport data example, for say if we have 6 data samples and the target value of whether to go to do the sport are half a half, and obviously we need to make more investigation to reach the final decision of whether to go to sport at this point. And see if we check how the samples are distributed with respect to the value on the attribute of wind. Say when the wind is strong, we have 4 samples, and the 4 samples has 3 to go and 1 not to go. And if the wind is weak, we have 2 samples are all to go. So in this way, we need to split samples in this way. And so according to the previous discussion, we will find that we need to do some more investigation in this group. And for this group, we can just return the red class. I remember I said not to go. Okay. Maybe in another step of the loop, we are considering the temperature. We are considering the temperature attribute. And if we split the samples according to the value of the temperature can be high and cool. It seems that in this case, the red color should represent to go to spot. At least these conditions are more comfortable. But this is, you get the point. This is just an example. So if we can split the samples according to the temperature, and if the split in this way, we will get two pure groups that neither of them will need further investigation. It's natural to see that at this step, if we ask questions about the temperature, it is more efficient than if we ask questions about the wind. So at this step, we should go, I think the information gain of asking questions about temperature should be higher than the gain that we can get from asking questions about the wind. So after we have decided that, okay, we want to go for the texture, then we will get down into the building process further. So when we reach the design step here, we may realize that, okay, at the input of the algorithm, we may also need the parent node, so that when we recursively call this procedure, we can provide the node itself as a parent node. Therefore, after all the building procedure, we will have a tree data structure automatically linked for us. We will see the implementation details in the tutorial video.